Alright guys, it's Mr. McCarthy here. I know I'm kind of backed away a little bit, but you can zoom in your camera much as you can. I came up here to the school, to the lab, to kind of show you the actual cylinders. This is an H cylinder. Remember the Hattie Patty Pies? So the cylinder factor is 3.14 for the H cylinder. And this cylinder here is the E cylinder. This is the E cylinder, which is 0.28, right? So I'll write them on the board. Cylinder factors. We have the E cylinder, which is 0.28. We have the H cylinder, 3.14, and the G cylinder is 2.41. These are your actual cylinder factors, okay? So remember, we talked about on yesterday in the lecture that you must start off with. So we have an 8 cylinder here. This is the cap that I told you about. See, this is the cap. All right, very solid, prevents the cylinder from falling over if that was to happen. The stem being broken. Okay, this is the stem here. From here to here, this is the stem. If something happens and hit that stem, this whole cylinder becomes a missile, okay? It becomes a missile. So when we get them, the lid is on like this, okay? The lid is on like this. We must first remove the protective lid, right? And then we have to do, what did I say? Cracking, right? Not cracking, right? You have to say cracking. What's going to happen is going to remove any dirt or debris from the orifice of the cylinder, right? So that's what we do. We see that? Turn it on, turn it off, okay? That blows any dirt and grime and dust from the cylinder. Now, who remembers what type of safety system goes with the cylinder? Right, it's the big ASS standard, right? The American Safety Standard, or American Standard Safety System, ASSS, right? And it is the nut and nipple, right? Nut and nipple. So I'll show it to you closer. This is a regulator for the big ASS tanks, right? Remember what I said to remember that the big ASS tanks, American Standard Safety System, which is your H tanks and your larger tanks, okay? We have the nipple. This is a nipple here, okay? This is the nipple and this is the nut, okay? It goes onto the thread of the cylinder, okay? Other things, on this side, this is the flow meter. Notice how I can change the liters per minute on this side, right? From 0 to all the way up to 25, okay? All right, this gauge here, which has the pressure, right? The PSI, can you see that? Shows you the PSI, right? Remember, 2200 is considered full. So at 2200, you see it's green and it says full, right? Most cylinders all cylinders at 2200 PSI are considered full, okay? This gauge and how this needle works, this is called the Bourdon gauge. This needle and how it works to read the pressure inside of the cylinder is called the Bourdon gauge. You'll see it in many different shapes and sizes, but it's all the same concept. It reads PSI, okay? Now, what did I say that the standard working pressure of all cylinders, when we want to bring this 2200 PSI down to what, right? All right, That is the standard working pressure. 50 psi. Standard working pressure is 50 psi. Don't forget that, guys. Okay? Whenever I bring the 2200 psi inside of the cylinder goes into the regulator. This regulator brings that pressure down at all of these ports to 50 psi. Okay? 50 psi. Now I can run my machines, right? So say I have a meta nail. Okay? This is my meta nail. It happens to have an oxygen hookup here, right? It has a thread. Now, this cannot go directly onto the cylinder. It's made that way so that you don't blow the machine or cause a pneumothorax. This machine works off of 50 psi of standard working pressure. Even on the back, it'll tell you. If you can see it, it says standard working pressure 50 psi. Okay? So in order to do that, this has to be hooked up to a regulator, which brings this pressure down to 50 psi, right? This is the magic regulator. All right. This will then screw on to the regulator. Okay? This will screw on to the regulator if this is on the cylinder, and now my machine can work. Okay? Now my machine can work at 50 psi. All right? Now, back to the regulator. We already cracked the cylinder. We took the lid off. We said cracking, open it up, turned it off. The next step would be to thread the actual regulator onto the cylinder. And this is the nut here, right? So just move it out the way. This is the nipple, so you might want to zoom in. This is the nipple. We will place the nipple right into the outlet, move the thread up to it, and just start to thread it on, just like a regular screw. Right? Get it on there. Now, with these cylinders, you must use a wrench. That is not going to be enough to seal this pressure. I'm going to have to use a wrench to tighten it up. These are special made wrenches that are used just for the American Standard Safety System. It fits all of the nuts of American Standard Safety System. Makes it easy for you, right? So I take this, remember I said lefty-loosey, righty-tighty. So I'll bring it to the right a little bit, nice little tug, and I don't have to lay on it, okay? And then I'm ready. I'll turn it on to see if it's tight enough. Oh, so I've turned it on now, okay? I've turned it on, and the pressure is up to, in this tank, about 1,000. So it's about half full, okay? It's about half full. Remember, you turn it all the way left, which is lefty-loosey. You turn it all the way on, and then a half a turn back to the off, right? And that is considered on. We're ready for business now, right? So, let's take a recap. Safety systems on the cylinders, right? First thing is color, right? This is a green cylinder, which means it's an oxygen cylinder, right? Then we have the American Standard Safety System on the large tanks, right? Which is the threaded nut and nipple connection, right? Then after the regulator, what do we call everything that's from here on? Everything after the regulator is the DISS, right? The Diameter Index Safety System. That is for all of the connections after the regulator, okay? Now I am ready to either plug up a pneumatically powered device, right? Or I can hook up, now, before I say that, on this regulator, since it's a large tank, the pneumatically powered machines, which I said means run by air, right, or gas, pneumatically powered. There is no battery, there is no electricity to this machine. it's run by gas pressure, okay? So, if you notice, they have little, the two places where you would hook this up to has two little spots inside that show you the 50 psi. So if you listen real close, I'm going to press the little needle inside of here. Hear that? That is for your pneumatically powered devices. The third one is what I would screw an actual binasal cannula to. It doesn't have the little needle inside here. It's just like letting the air out of your tire. You know, you have your tire and you push that little needle and you can hear the pressure come out. Well, that's what these two connections are for, okay? I can hook two pneumatically powered machines to these two connections here, all right? Or if I just want to do a nasal cannula, then I can do my nasal cannula or aerosol face mask or anything else like that from this connection, right? That happens from this connection. All right. Now, remember what we said about taking it off. First thing you have to do when you're ready to take off the regulator is to turn the cylinder off, right? We turn the cylinder all the way off, and you will notice that there's still pressure inside of the bourdon gauge. The regulator is still showing pressure. So how do I get rid of that pressure? I cannot take it off until I get rid of this pressure. We call it bleeding the pressure. We have to bleed the pressure first, right? So what I do is I just turn my leader flow, either turn it all the way up, and you see that? Just went down. Now it is free of that 50 psi, right? It's free. Now I can remove the cylinder. Okay, so I take my special wrench. I go back to the right. Regulator off. Okay? That, guys, is how you start to finish put on a regulator to the correct cylinder. Okay? Now that will be the big the ASSS cylinders. What about the smaller cylinders? It's the pin index safety system. Right? So here we go. This is a regulator that works off the pin index safety system. If you can see it, it has pins. It has one big place and two small pins there. Okay? All right. Remember the position for oxygen, and remember the position for CO2 and the position for air. They all are different, right? So here it is. This is an E cylinder. This is an E cylinder. If you notice, the E cylinder also has on one side 3 pinholes. One big one and 2 small ones. On the other side, it's just a little notch to catch the actual yolk, right? The yolk, all right? So all I do is I line that up. I take the 3 pins on this side, line it up with the 3 pins on my PISS, right? The little pissant tanks, right? The PISS, the smaller cylinders, right? I put this over like this and just work it until it fits right up into the spots, right? 1, 2, 3. Once it fits in there like that, it's snug. I have it flush and it's in there. What I do then is just simply tighten the yoke. Tighten the yoke, right? Now I'm ready to turn on the cylinder. Now, quick question. What did I not do before I put on this regulator that I should have? A crucial step that I did not do before I put on the regulator. I'm gonna let you think about it. If you said I didn't crack it, then you would be correct. I did not crack it. Now, I went to get the tank wrench. The cylinder wrench or tank wrench for an E cylinder looks like this. and this part fits over the top, right? So let me take it back off and correctly crack the cylinder before I put on the regulator. Now let's see. Lefty-loosey, righty-tighty, always, okay? Always. So I'm gonna put this on here, turn it to the left, turn this away from you and away from everybody else and say, cracking. See that? That's what you do. Now, we know all the dirt and debris has been removed from the actual orifice. Again, I take the 3 prongs, line them up with the 3 holes on this side, just fit it right down over there and just till I feel it catch and it's flush. It's flush. I take the yoke and tighten it up. Then I cut on my cylinder. Let's cut it on and see if we have a leak. Same thing with the E-cylinder. You will turn it all the way till it stops, and then 1/2 turn back to set it. Okay? Now it's on. Now, when I look at my pressure inside of here, you see that pressure in the board-on gauge? It's reading about 500. It's almost empty, right? This cylinder is almost empty. Okay? That's how we would know. When it gets to about 500, you want to retire that cylinder, put it in the empty, and get you a new one. All right? But we cracked it, we put on our regulator, and we turned it on. This cylinder or E-cylinder would be ready for use. We can plug a nasal cannula up to this one, right? Nasal cannula, small bore tubings, that's the kind of things, low flow systems is usually what we use on the E-cylinders, low flow systems. Okay? Now, I'm ready to take it off. So the first thing I have to do is turn the cylinder off, right? So let's turn the cylinder off. Righty-tighty. Off, okay? Now, I have to bleed that pressure, right? Because there's still pressure inside of the regulator. So I'll turn the flow meter, right? And it goes down. Now I'm ready to release the regulator. Okay? This is how you engage and disengage E-cylinders and H-cylinders. Okay? All right. Don't forget, there's also some safe storage or safe handling. This is an H-cylinder. It should always have its lid on it. I told you it sounds real scratchy, but it's necessary. And why would not put oil on here to make that less hard to turn or less scratchy? What would be a reason I would not put spray oil on there? Exactly, because it supports combustion, and oil is a product of petroleum, and it's considered flammable. The oil is, okay? But the oxygen cylinder is not flammable, but it supports combustion. All right, so how I stand it up, it's like this, right? This is how it should be stored with a chain around it. Now, when I'm ready to move it, I just have to lean it back, and these wheels pop out, right? There's some wheels that pop out, and it kind of leans to the side. Hold it with 2 hands, and this is how I would manipulate moving the H-cylinder, okay? You'll never go behind you. Always keep it in front of you so you can see what's going on, okay? This is the safe way to move or manipulate the H-cylinder, all right? And when I'm done manipulating it, I take it to where I'm going to put it and stand it up. All done. The E-tank, or the E-cylinder, is always on these little cart stands, right? It's just a stand with 2 wheels, and you keep it in there, and this is how you move it around, okay? We'll roll this one around like so, okay? That, you guys, is basically the cylinder lab, okay? That's the lab. So look at this video, watch me put it on and off, talk about the different components, and be ready to check off when, if we ever get a chance to come back together and do this. If not, just keep watching it and you'll know what to do whenever you do get a chance to put your hands on one, okay? Remember our cylinder factors, and to find out how long a cylinder lasts, right? We have to do factor times PSI divided by the liters per minute. This is the duration of flow. That answer is going to be in minutes. You have to then divide that by 60 to get the hours. And after that, if you still have a lot of hours, you can break that down to days by dividing it by 24. Okay? This is the first recorded session of a lab that I have done. The next lab that we do, which is aerosol and humidity, I will do the same thing. I will come in and hook up aerosol humidity, let you see it in action, show you all the components and high flow systems, low flow systems, humidifiers, aerosol treatments, all of those things. I will try my best to come in and perform them for you so that you can see them and always go back to them. This video and other videos will be loaded into the module, into Canvas, for you to watch at any time. I will publish it and you can watch it at any time. All right, guys, study. Get in your book right now and look over this stuff. And I will see you again on the next class time. Goodbye.